So in 4.3, we introduced this number e. What I want you guys to do is all go to your calculator, whether or not you have the app or an actual calculator, go to your calculator. If you look right above the division sign, so I know you can't actually see my screen, but if you go to the second button and then go just above the division, you should be able to see a tiny little E here above the division sign. I want you to hit that division sign if you've already hit second. So second division sign. You should pop up a little E on your calculator. Just an E, nothing else. Has everyone been able to find that? Okay, I want you to hit enter. Hit enter on that. If you have a newer calculator, it might stop for you. But I'm getting 2.718281828, and so on. So what this number is it's called an irrational number. It basically is a repeating decimal, not a repeating decimal, it's a decimal that goes on to infinity. There's no set pattern to it. It's very like the number pi. Okay, if you guys also wanted to try this out for pi, you would get some big, long, nasty decimal of 3.141592654, and so on. So E is like pi in the sense that we at one point in time had this huge, long decimal. E is a very specific number, and it was a number that we were able to use when talking about logs, when talking about some graphs of functions. It's a very specific instance that happens. And instead of always just calling it this big long decimal, they named it E. It's in the exact same way that while pi was very important to our math process, that they named this long decimal 3.14 by using pi. So it's one of those that in your calculator, instead of typing in this long decimal, whenever we use the letter E, you can actually just hit that second and then the division button. So ways that we use E in math is mostly when we're going to get into what's called logarithmic functions. But there's other uses for it too. Specifically, we're going to have a new kind of compounding in order to find an interest rate, or how much money is in your account after using that interest rate. Oh, sorry, I thought somebody was trying to get added in. So what I want you to remember is that E can be used just like any other variable in math. So let's say I had an E to the second times E to the fifth. If E was replaced with the variable X, when you have the same base, you simply add their exponents. So it would become E to the 2 plus 5 or E to the 7th. Okay, let's say I had 5E plus 2E. Right now I'm going to have 7E. The whole point of this is that when you're using the variable E, you use it like you would any other variable. And I think it's really hard for us. We get caught up in like oh my gosh, it's E, it's a weird number. It's just like once we start getting into trig functions with pre-calc, everyone starts freaking out when they see the letter pi or the number pi. They're like, oh my gosh, I don't know what to do with it. And you use it just simply like you would any other symbol in math, with any other variable in math. So it takes the same kind of graph as a normal exponential function, but there's a specific thing I want us to do with this. Us being able to graph this is not incredibly important to me, but there is one other thing I want to talk about. So I want you to also find one other thing on your calculator, and that is going to be the ln button. Okay, it goes, let's see, this is x squared log and then ln. When you type that ln button, you're going to just get a parenthesis that pops up. There's nothing you can particularly hit here to give you like a number that this stands for, but what this ln stands for is a log base e, is what natural log is. So ln equals log base e. Have you guys at any point in your life talked about log functions? Give me like a yes. Yeah, I didn't think you had. So this log probably looks a little bit funny to you, but tomorrow you're going to learn a lot more about this. This is kind of like a tidbit into why are we even learning about this E letter. Okay, so natural log and log base E go hand in hand. They equal one another. That's a precursor for tomorrow. So what can we use E for today? So let me take you back to yesterday's equation. It was A equals P times 1 plus R over N to the NT. When we used this, it was because we had this N. A new equation I want to introduce you to today is A equals P E to the RT. What's missing in this equation? My N value, right? Very good, guys. My N value. There's an N value here. There's no N value here. So what does that mean for this function? If we're not calculating the number of compoundings per year, in this function, what that means is that there's no specific amount. Okay, so you're gonna be wondering what the difference is between these very soon. The difference is this is for a set number of compoundings. Okay, a set number of compounding. So this is again, for an example, let's say you're going to compound daily, monthly, yearly, semi-annually, quarterly. All of those things use this function because there's a set number of compoundings. Once we get to this function over here, when we're using that equation, this is for continuously compounding. So this is a really new thought for us. We are very used to saying you're going to compound at the end of every day or the end of every month, the end of every year. With this function, we are now continuously compounding. What does that mean? It means every single second of every single day, you will be getting paid your interest. So at the end, so that money's just continually flowing into your account. You might be getting paid less than a penny in that second, or less than a tenth of a penny in a millisecond, right? But no matter what, your account is building up that interest over and over and over and over and over and over and over. It doesn't mean that you're necessarily going to be paid a ton more money, but it means you're getting paid money all the time. It's not you have to wait until the end of these few months until you get that money. It is you get paid that money every second of every day. So let's put this one to use a little bit. Okay, I'm going to give you an example. So let's say, you can see this. Alexa, deposits for, and you can't see there's my money sign. Alexa deposits $4,000 with 6% interest. That's a not very lifelike interest rate. But we're just going to use it for the heck of it. With a 6% interest rate, Alexa deposits $4,000 with 6% interest rate, and it's compounded annually. Not annually, continuously. Okay, so what I want you to do is I want you to find the balance in her account after 1 year. Good question, Raylene. So you can't exactly use this for a salary, because a salary is still something that's like, when I get my paycheck, I get my paycheck. We get paid bi-weekly, so we get their paychecks on the 10th and then the 25th. So with paychecks and salaries, you're getting that money on a very set date. This is specifically going towards interest. So say you did take that salary and you went and deposited it into an account that had continuously compounding, that would be where you could use this kind of equation. So let's identify our big numbers here. We need 3 things this time. We need a p-value, an r-value, and a t-value. Remember, we don't find a value for E, that's a button in our calculator. So P is again the money you invest. So you are investing, or Alexa is investing $4,000. The interest rate is 6%. Take that decimal, move it 2 times to the left to get 0.06. T time, we're only going to invest this for 1 year at the current moment, and then we're going to reevaluate after that. So the way I like to remind students of this is you can always think of this as PERT, right? PE to the RT. So we start with our P, that is $4,000. This is multiplied by E, taken to the power of R times T. So what is 0.6 times 1? Anything times 1 is just itself. So you can do 2 different things. You can write out this step, or you can just know, well, when I have 0.06 times 1, or 0.06, I said it right the first time, you just end up with 0.06.
Miss Nordman?
Yeah.
Can you move the camera down?
Oh, sorry, can you not see it? There you go. Better? Okay. So let's plug this into our calculator now. Again, do we all remember how to find that E button? You go second division. So you type in your 4,000, and then you go second division to pop up an E. It should look just like it does here. Then you can take it to the power of 0.06, and you should be getting a number just a little bit above 4,000 here. Okay, so again, 4,000, find that E button, and then use your exponent. There is $4,247.34 in the account after 1 year. Questions, questions, questions. Any questions at all? So let me ask you, any of you that were confused, are you more confused now, or does this kind of help you to move on to something that kind of describes this more? How do you plug it into the calculator? Again, Taylor, you go to second division button. So I'm trying to find your guys' homework really quick. So you go to the second button, it's usually over here above alpha, and then your division button. You should see a tiny little E above it. So I want you guys, for homework for today, this is going to be on page 249. And let's do numbers. 57 and 58. Just 2. It'll give you 2 practices of continuously compounding, 57 and 58. Those are 5s, by the way. They kind of look stupid. $57, $58. Guys feel like you're good to be able to do that tonight? Okay, again, if you end up having more questions on last night's homework, bring that back to me tomorrow. You can also email me too, and I can kind of try to send you some solutions. If you are confused on this homework, bring those questions to class tomorrow. You guys excited to be back in person? Except you, Jenica. We'll see you on Zoom. All right, bye guys. And Jenica, remember, I will tune into Zoom. So I'll open up my Zoom so you can still watch class in session.
So your
If you want.
Zooms during class?
What's that?
Your Zooms during class?